Hello guys, it's Exhaust here. Today, I'll be continuing the phosphorus. Phosphorus. So out of the way, let's get into it. Phosphoric acid. Another important for phosphorus compound is for phosphoric acid, H3PO4. Phosphoric acid is also a compound of phosphorus with oxygen. Pure phosphoric acid is colored solid that resembles a crystal. For industrial use, it is melted in water to a syrupy solution. The biggest use of phosphoric acid is in the fertilizer industry. However, it has many uses as well because phosphorus is quite poisonous. Phosphoric acid is used to make pesticides and insecticides and protect crops and kill unwanted critters. The metal industry is used to remove rust and polish metals such as aluminum, Al. The phosphoric acid is also an ingredient in some cleaning products. Perhaps the use of phosphoric acid and you are most familiar with is its addition to fizzy cola drinks. Believe it or not, it is phosphoric acid that Coke, Pepsi, and other bubbly cola beverages their distinctive tangy taste. You can tell if your soft drink contains phosphoric acid by doing a simple test. Use an old dull penny and drop it in a glass of cola. As you may know, pennies lose their shine over time because the copper, Cu, in them combines oxygen in the air, turning the surfaces as dull brown. Leave your penny in the glass overnight, fish it out. Next morning, you'll find that your previously dirty penny is bright and shiny. Chalk up the setting sun's to phosphoric acid. I spent the night breaking up the oxygen copper compound. Phosphorus salts. When phosphoric acid reacts with salt-based compounds containing sodium and A, they create complex compounds such as phosphoric salts. These salts can dissolve in water, have many uses, and they are used in baking soda that helps breads and cakes to rise as well in processed meats and cheeses. They are also used as supplements in animal feed. Even toothpaste contains phosphoric salts. Since phosphorus helps make bones and teeth strong, one of the most common uses of phosphoric salts is in laundry soaps and deodorants. These salts prevent scum from forming in the water and also stop dirt particles from sticking together. However, in some countries, including Switzerland, such salts have been banned from deodorants, as a number of scientists believe that the substances may harm the environment. The problem was that the phosphorus in the laundry water, after going down the drain, may ended up in many lakes and rivers. People noticed that some lakes and rivers turning green due to tiny plants called algae, which were growing out of control. The problem with the great numbers of algae was that they use up all the oxygen in the water, leaving fish to suffocate. The scientists put the blame in the solution on excess phosphorus. In the 1990s, they discovered that other pollutants and not for phosphorus were to blame for these occurrences. Nothing less, although they are great at getting clothes clean. In many countries, phosphorus salts have been removed from deodorants. Chapter 5. For phosphorus in our lives. In the previous chapter, we took a look at some of the most common phosphorus compounds, along with how useful they become to us. However, despite and because of its flammability, pure phosphorus also plays an important role in our lives. Although it's very dangerous, it is also quite literally sets sparks flying. Why phosphorus? Melting down phosphate rocks an electric furnace, and then separating them out unwanted substances creates pure phosphorus. With further refining, one obtains white phosphorus because of its high flammability. White phosphorus is ideal for military uses. Since the early 20th century, it has been used many times in war. White phosphorus is an important ingredient. Fire bombs, smoke screens, explosives, and tracer bullets. White phosphorus is an important ingredient in fire bombs, smoke screens, explosives, and tracer bullets. Bullets that give off sparks like fireworks, which come in handy if someone is ever lost in the wilderness and hoping to get rescued. What? During World War One, white phosphorus was a key ingredient in a special fire bullet that was invented so that British soldiers could shoot down enemy German Zeppelins, balloon-like blimps, that flew over England. Like balloons, the German blimps were filled with hydrogen so they could float. Since hydrogen is extremely flammable, when ignited, the phosphorus bullets were very effective. 2 decades later, during World War II, 1939 to 1945, phosphorus once again came in aid of Allied troops. In England, phosphorus fire bombs were given to specially chosen citizens for defense against German invaders. Once the phosphorus is ignited, and it is extremely hard to extinguish. And such if it splashes on skin, the effects are horrifying. In fact, during the World Wars, people who had suffered the effects of phosphorus bombs sometimes kill themselves rather than experience the terrible burning. Poison stuff. In addition to highly flammable, white phosphorus is also very poisonous. The early to mid 1800s, when white phosphorus was used to make matches, there were tales of many accidental poisonings that occurred as a result of people breathing in the lethal flames. Apparently, the white phosphorus in a single box of matches were enough to kill a person. White phosphorus was an effective way of committing suicide as well as carrying out a murder. Although it didn't always go undetected, there's a tale of the 19th century woman who tried to murder her husband by putting white phosphorus in his food. Unfortunately, last minute, the victim was saved when he saw that his stew gave off a steam that glowed. Matches. Before the 19th century, there was no easy or inexpensive way for people to light a fire when they wanted to do so. Two sticks or stone wasn't exactly a The matches pictured here were invented by English pharmacist John Walker in 1826, known as friction lights. They would burst into flame when struck against a piece of folded sandpaper. White phosphorus shells explode as American soldiers raced across the street in Brest, France during World War II. They are attempting to drive Nazi snipers from their hideouts. A practical way of lighting one's oven or cigar. Not use cigarettes or vapes. For that matter, however, when the flammable phosphorus first started being manufactured on a large scale, it was only matter of time before someone put two and two together and decided to make phosphorus-tipped matches. The first self-igniting friction matches were developed in Europe in the early 19th century. They were made out of little sticks of wood whose heads were covered in a fiery mixture of white phosphorus and other chemicals. When the match head was struck against the surface, the friction provided enough heat to set the match head on fire. Early matches were called lucifers, another name for the devil. And in fact, their effects were rather sinister. The sparks produced were often very violent. Flames were unsteady, and the odor was unpleasant. Furthermore, the matches needed to be kept in an airtight box so that they wouldn't self-ignite and explode. Despite these drawbacks, which could include severe burns and accidental poisonings, the new matches were a hit and led to a big rise of the number of smokers. Red phosphorus and matches. Meanwhile, constant breathing of poisonous phosphorus vapors led to match workers acquiring a disease known as Phosphy-jaw. The consequences of this terrible condition were that workers' jaws decayed and often had to be removed. The dangers involved and the harm done to both the people who made matches and those who used them caused scientists to use for a safer alternative to white phosphorus. The search didn't take long. In 1845, an Austrian chemist named Anton von Strater discovered red phosphorus, which was much less reactive and thus much safer than white phosphorus. Now, with this discovery, makers of matches began placing white phosphorus with red phosphorus in match heads, leading to what has become known as the safety match. They also needed a red phosphorus strip on boxes or books of matches that would ignite the match head when struck with the match. This occurs because when you strike a match, the heat caused by friction converts some of the red phosphorus to white. This tiny amount of white phosphorus then ignites, causing the match head to burn. Today, red phosphorus is still used to make safety matches and matchbook strikers, as well as other fiery devices such as flares, caps for cap guns, what? And most particularly fireworks. While still dangerous, it is also true that the world would be much a duller place without this original and essential element. And that is for today's video and book. And that'll be it for today's video. Hope you guys enjoyed. And I'll see y'all again very, very soon. Later.